Alright, today's lesson is section 3-3, linear functions. This section will be broken into two parts to help minimize the length of the videos. So let's get started. Notice the hidden word in the word linear. It's not a near ear function. We're going to talk about lines. So we're going to talk about functions of lines. A linear equation is just defined as the equation of a line. Like, it's not being tricky. It's being very straightforward. So anytime you hear about a linear equation, it's talking about a line. The graph of this equation will look like a line. The standard form of a linear equation is set up as ax plus by equals c, where a and b are not both 0, and a, b, and c are integers with the greatest common factor of 1. So we try to simplify as much as possible. If they have a greatest common factor other than 1, we try to divide by that greatest common factor and reduce down to whatever we can get to. Okay, so determine whether each equation is a linear equation. Remember, we're looking for ax plus by is equal to c. All right, remember, a or b can be 0, but not both. And notice how x and y are just by themselves. They're separate. They're not together. So they're to the first power. Those are the things we're looking for. So for a, y equals 5 minus 2x. Well, absolutely. Okay. So if we notice that y and x are by themselves, their coefficients are both not 0. So this is a linear equation. So yes. And then it says, write the equation in standard form. Well, standard form has x and y on the same side, so we are going to add 2x to both sides. So we get 2x plus y is equal to 5. And there is our standard form. Because notice 2, 1, and 5 are the greatest common factor of 1. So we're done. B, 2xy minus 5y equals 6. Well, looking very closely, we have an x times a y. That is not in standard form because there's an x times a y. We can't have that in standard form. So no, this is not a linear equation. So we're done. All right, then let's talk about some parts of the function themselves. The zeros are for values for x when f of x equals 0. Now, in a previous lesson, we talked about how f of x is actually just y. So f of x is just y. So really what we're saying is when y is equal to 0. Okay, the x-intercept is the point at which the graph crosses the x-axis. Okay, and then the y-intercept is the point at which the graph crosses the y-axis. So if you think about this, looking at the graph, at the y-intercept of 2, the x-coordinate is 0, and at the x-intercept of -4, the y-coordinate is 0. And so if you kind of do a little thinking here, the x-intercept is when it crosses the x-axis, and the 0 is when y is equal to 0. So in this example right here, the y-coordinate is 0, so y equals 0. So actually the x-intercept is the same as the 0. So x-intercepts and zeros are just synonyms. They mean the exact same thing in context. So it really helps us if we know that and we can limit our work. All right. So high school students in Palo Alto, California can buy ticket booklets for lunch. As shown here, determine the x-intercept, the y-intercept, and the zeros. Well, remember, x-intercept and zeros are the same thing, so we can identify both those at the exact same time. So I'm going to say the x-intercept, so let me do this in red. The x-intercept is right there. The 0 is also the x-intercept. And then the y-intercept in blue is where it crosses the y-intercept, or the y-axis. So there is our x-intercept, y-intercept, and 0. So describe what the intercepts mean. So if we look at this, the y-intercept is when the number of meals purchased is 0,16. So number of meals purchased 0, so booklet is worth $60. So no meals purchased booklet worth $60. All right. And then for the x-intercept and the 0, that means we have 20 meals purchased and booklet worth $0. All right. Okay, so use the graph at the right that shows the cost of the gym membership. So in this one, if we look at it, it's just a horizontal line. So we can see that y-intercept is right there, but at 0,150. But there is no x-intercept. So if we realize what the y-intercept is saying to us, then we can look and say, well, at 0 months and paying $150, so that tells us initial cost is $150. And the rest of the graph just tells us that the monthly cost doesn't change. It's just every month you pay $150. So it's a constant rate. It's a flat rate. You might have heard of those before. Okay, so use the table to determine the x-intercept, the y-intercept, and the zeros. So if we remember, the x-intercept and the zeros are the exact same thing. So x-intercept, I'm just call it xi. That looks like a t actually. X-intercept is, remember, it's when the y value equals 0, so right here, so it's -2, 0, and the 0 is the same thing, so it's also -2, 0. All right, and then the y-intercept is when the x value is 0, and that would be 0, -4. So that ends this part of the sections.